Hey guys, so continuing with our conversation about linear functions, today we're going to talk about slope. And when we're looking at the slope of a line, we're looking at just specifically how steep the line actually is. So slope is actually the steepness of a line. Okay, you may think of it as like a ski slope. You've got like the Dead Man's Hill, which is a pretty steep slope. You have the Bunny Hill, which is almost, a nice, comfy little skiing slope, perhaps almost like a horizontal line. You're not necessarily going at it a huge measurement of an angle. So in order for us to figure out slope, there's a couple of things we have to think about. All right. What we're looking at is we're looking at two specific ideas. We're looking at the rise and we're looking at the run. Okay. The rise is the vertical change. Or if we're looking at it, we might say vertical, remember, is we're always trying to improve our vertical. You hear the term vertically challenged. So we're looking at our change in Y values. Okay? The run is our horizontal change. Horizontal, remember, is the horizon. It's side to side. And so this one, we're looking at the change in our X values. Okay? So if I'm thinking about this, one way that I might think about this is the idea of slope, where slope is our change in our Y over our change in our X, which is our rise over run. Another way that I like to think about it is by saying slope is rise over run. Now, yes, I am very aware that I spelled the word rise wrong, but I did that for a reason. And I want you to think about what that reason could potentially be. And if you're thinking to yourself, because it's the change in Y, so the rise goes on the top, with the rise being spelled with a Y, then you're exactly right. Okay, so this is key. This is important. All right, we're looking at our change in Y over our change in X. So let's look at a couple examples. The first example we're going to look at is letter A. And we're going to determine the slope of the line. Okay? In order for us to determine the slope of a line, what we need to do is we need to figure out specifically these 2 points, or at least 2 points on the line. Easiest way to determine 2 points on a line is to look for a perfect intersection. So for example, this is a perfect intersection right down here. There's a perfect intersection. It looks like, well, through the origin at 0, 0. You've got another perfect intersection, at point B, which is 0.54. So you want to find exactly where it's going to cross and make that perfectly nice intersection, or that perfect cross for you. Okay? Now, we read a graph just like we read a book, okay? So what we need to remember is that we read a graph from left to right. Okay? And this is key, because when we're trying to figure out how to determine our points and figure out our slope, we need to realize how exactly we're reading this graph. Okay? So we're going to read this graph specifically from point A to point B. Okay? And if we are looking at this, what we're going to do is we're going to start at point A, okay, which happens to be my origin. And remember, my formula for slope is, slope is rise over run. And in order for me to get our rise, we have to look specifically at my Y value. And what I'm going to do is I'm going to rise, in this case, from point A to point B. I want to rise up 1, 2, 3, 4. Okay, so I'm going to rise up a positive 4. Okay, and then I've got to get over to my other value, or my other part of the B. So from there, I'm going to run 1, 2, 3, 4, 5. So to get from point A to point B, I would go up 4 and I would go to the right 5. Well, the right on my number line represents a positive. So if I'm looking at it in that perspective, I've got a positive 5. So in this case, I'm going up 4 and right 5, which is the same as positive 4 over positive 5. So my slope in this case would be 4 over 5. So the steepness of this line is 4 over 5. Okay, so that means every perfect intersection, or every intersection in between, is going to have a slope of 4 over 5. Well, we can test it on this bottom one down here. Okay, the one that we marked. So we can say, all right, well, 1, 2, 3, 4. And then I'm checking it. 1, 2, 3, 4, 5. 4 over 5 again. So I know that I've got my slope correct. Okay, let's look at the next one. On letter B. All right, I want you to try this one. Pause your video. You try your rise and your run and see what you get. So you should have found that you rose up 2. So that was a positive 2. And then you went to the right 2. Okay? And so a 2 over 2 would simplify your fraction into 1 whole. So in this case, your slope in this problem is 1. Okay? Well, let's look at letter C. Letter C is a little bit different. Okay? This time, you're sliding down. Okay? The first 2 problems, if you go back and you look at it, it looks like you're climbing up a ladder. Okay? This time you're sliding down. So it almost makes you think that if you're sliding down, you should be going into the negatives. So let's see. We still read the graph from left to right. Nothing changes in there. So I'm going to start with point A. And I'm going to go down 1, 2, 3, 4. Okay, so I'm going down 4. So down 4 means it's going to be a negative 4. Okay, and then I'm going to run 1, 2, 3. All right, so I'm going to the right 3. So that's going to be a positive 3. So in this case, my slope is negative 4 over 3. Now, if you remember, I'm a big fan of fractions, and especially in this unit, okay? Because when it comes to graphing, you're going to use your slope to help you graph your points, okay? So when you're graphing your points, you want to keep your slope in fraction form. By doing that, that allows you to easily and quickly access the next point. And when we get to that graphing portion of this, you'll understand why. All right, let's look at letter D. All right, you try letter D, pause your video, you try it, and then come back and check and see how you did. Okay, so you should have started at the point negative 3, 4, because remember, we're working from left to right. So we start at negative 3, 4. We have to travel down 1 to get to the next level of the point. And then we go to the right 3, so our slope is going to be negative 1 over 3. Okay, well, let's look at letter E. Letter E is a little bit different because you've got a problem. It's a horizontal line, okay? And this horizontal line is going to be really important to us when it comes to a slope, okay? When we talk about a horizontal line, well, think about it. It's looking from side to side. We're not moving up or down, okay? we're still going to take and we're going to start from left to right. So I'm going to start at that -3, -2, but I can't go up anywhere, nor can I go down, because the point is on the same area, meaning like I'm not going at any kind of an angle. So I'm not going to have a change in y. So there's no change in my y value, but let's see if there's a change in my x. All right, well, let's see. If I start at that -3, -2, I'm going to go 1, 2, 3 to get to that 0, -2 point. So I'm going to go to the right 3. Well, that's the same thing as saying 0 over 3. And 0 divided by anything is 0. So the slope in this case is equal to 0. Now, this is important because the horizontal line, all right, this is really, really key here. So the horizontal line has a 0 slope. It's not saying it doesn't have a slope. It's saying the slope value is worth 0. Okay? The slope value is worth 0. And that makes sense because I'm not moving up or down. Okay? Well, on the same token, look at letter F. Letter F is going to be a little bit different because in letter F, you're dealing with a completely different line this time. Letter F, you're dealing with a vertical line. Okay? And in your vertical line, you should notice that, okay, well, there is a change in my y. Okay, I'm going to start at the 2, 1, and I'm going to go 1, 2. Okay, so I'm going to go up 2, which is the same thing as a positive 2. But in terms of my change in x, well, there is no change in x in this problem. Okay, my x doesn't change, and you can see that if you look specifically here and here at your two ordered pairs. Your x's are identical. Okay, there's no change in my x values. So if there's no change in my x, well, that's divided by 0. So a positive 2 divided by 0, well, anything divided by 0, if you take that and you plug it into your calculator, you get the letters ERR, or error, okay, because it doesn't exist, all right? You can't, so there is no slope in this problem. There's no slope in this problem. It's what we call undefined, okay? It's an undefined slope. All right, and the reason why it's undefined is because you can't divide by 0. Okay, you end up getting an error in your problem. All right, well, let's go ahead and let's look at the next portion of your notes. And you should see that this is a little bit different. So the front side, you were looking at how to find the slope when you're given a graph of 2 points or more. In this case, you're going to determine how to find the slope when you are given just 2 points. Okay? So this is one of the most important formulas that you need to know. All right? And if you can remember this formula, then you are gold when it comes to part of this unit. Okay? This is one of the formulas that you will be using a lot on your SOL. Okay? And in this case, we call slope the letter M. And you'll understand later why we use the letter M for our slope. But if you look at it, you've got the change in y, which is your y2 minus y1, over your change in x. which is your x2 minus x1. Okay, where the x's can't be equal to each other, because if they were equal to each other, if they're the same number, then you're going to get that 0, and therefore it's going to be an undefined slope. Okay, so let's take and let's determine the slope of the line that passes through -2, -5, and 7, -10. Well, the first thing you got to do is you got to figure out what's your first value and what's your second value. In this case, your -2 is your x1. Okay. And your -5 is your y1, which means your 7 is your x2, and your -10 is your y2. So what we're going to do is we're going to take and we're going to set up this equation using this problem. Okay, I want you to get used to writing this formula. So you're going to say m equals y2 minus y1, which is the change in y over the change in x, excuse me, the change in y over the change in x, x2 minus x1. It is of vital importance. It is so important that you write the formula in this format, because if you don't, you're going to end up getting a negative when your slope should be positive, and or vice versa. So now what we got to do is we just got to take and we have to substitute in our values that we need. So here we go. So you've got y2, which is -10, minus y1, which is -5, over x2, which is 7, minus x1, which is -2. Well, right now you should automatically start to see that there's a minor problem taking place. Okay, you have a minus a negative in both of these. Okay, so what you want to do is you want to rewrite it so that way you can see it as a -10 plus 5 over 7 plus 2. Well, -10 plus 5 is -5. And 7 plus 2 is 9. So what you can do is you can take and you can leave this in this fraction form. Your m is going to be worth -5 over 9. This is a negative slope. It's obvious because it has that negative sign there. But that also tells me that my line is going to be going down. Okay? So m equals -5 over 9. Well, let's look at our second problem. Okay, we're going to find the slope of the line that passes through 7, 4, and 9, -1. Okay, so if I'm looking at 7, 4, and 9, -1, I need to figure out, okay, well, what's my x1 and what's my y1? What's my x2 and what's my y2? All right, I know right now that my formula is m equals y2 minus y1 over x2 minus x1, my change in my y over my change in my x. Okay, what I want you to do right now is take and pause this video. I want you to determine what your x2, excuse me, what your x1, your y1, your x2, your y2 are, and then come back and check and see if you're on the right track. You should have found that 7, 4 was your x1, y1, and 9, -1 was your x2, y2. Okay, so now what I want you to do is, using that information, I want you to substitute in and I want you to solve. So pause your video, substitute, and solve. So you should have found that your slope was -5 over 2. Again, remember, leave things in fraction form, especially like this. Leave this in an improper fraction form. Don't take it any further, okay? If it can be simplified, that's fine, but do not change this into a mixed number. I'm telling you, you need to trust me on this one, that it will come back and it will be beneficial on your behalf if you do not change this, okay? So this is what we're doing for today, and then next time we meet, we'll continue with the remainder of our notes. Good job today.